Hello, good evening here. If you are in Brazil, good afternoon, good morning, wherever you are. We are starting one more session of out of the box developers. Actually, it is a special session today because we have one of Java champion, professor, speaker, consultant, Professor Isidro here to share with us some of the most fundamental tools or most fundamental knowledge to use as tools to solve complex problems. So I just want to say hello, Isidro. How are you?
Oh,
And
you go.
we're very happy to have you here.
I'm very proud to be here. For me, it's an honor to be with you, with Luis, and with Igor. Talking about, I could say that it's not easy subjects to talk about foundation data structures, computer networks, or algorithm analysis, but I think it's can be a very interesting conversation because we can explore things that we could see a little bit ahead of our headlines when we receive lots of information through the social networks. So let's try to go a little bit deeper than the headline.
Well, that's great. That's great. Yeah, because e- every time we need to use some those concepts, and as much as we know, better we can become as a professional, right?
Yes. And I usually say to my students, and what's the main point in our career? Of course, you have a very difficult task. It's to get in to the market, to start working, to get the first job, the first opportunity. But even more difficult is to keep up to date because every day you have a new tool, every day you have a new framework, every day you have a new programming language, if you can say that. But how can you stay up to date having a very strong basis, a very deep concepts on your knowledge? Why? For example, last 5 or 10 years, 10 years, okay, 10 years, it's a very, very good time. Nobody talked about containers. It was very difficult to talk about containers. And nowadays, every cloud native application use containers. But what are containers specifically or particularly? Process on an operating system, isolated process on an operating system. But how curious could be if you are a Windows user, you can use portable applications. What are portable applications? Applications that you don't have to install to set up your machine. If we can make a little bit parallel about containers, containers could be considered portable applications because you have your specific file system, you have your specific libraries, you have your specific tools and anything about your application, your service that are isolated from the rest of your operating system. It's not virtualization, but isolation. So if you study a little bit about operating system, you can understand how Docker or Kubernetes can work internally. If you study data structures, you can understand how, for example, Java Reflection works internally. How your favorite framework, even though Quarkles or Spring or Micronaut or whatever, work internally. And you can be a much better user or a more skilled user, a developer, to if you know how this frame works internally and how to get the best of this framework. So I think that the main idea of this talk is to talk about these concepts and what we can have hidden behind the technology of our day by day tasks.
Great. Yeah, that's amazing analogy, and just by this example, I can see lots of things that we can benefit by knowing better. A lot of some of the fundamental
Yeah.
concepts, and
Yes.
and yeah. So today, to contribute with the discussions and questions as well, I'm here with Luis. Hello, Luis. How are you, man?
Hello, everyone. I'm very happy to be here because it's an honor to be here with Professor Isidro.
Oh, come on.
And it was a great introduction about the subject, what you already told here about the containers and this analogy. And I just want to say that I got a haircut today just to look good beside Professor Isidro in this video.
I missed my haircut today. Oh my god.
Oh my!
So, Professor,
You exposing myself as well.
I tried, but I
Yeah.
couldn't.
it's really an honor, and I'm very happy and thankful for you to accept our invitation.
Oh,
So
thank
thank
you
you.
so much,
Yeah.
Amazing,
Luis.
amazing. Yeah, and also we are here with Igor Fraga. Hello, Igor. Good to have you here.
Hi, Hugo. Hi, Luis. Hi, Professor Isidro. It's a pleasure to have you here, Isidro. We have spoken at the beginning of this year. You will not remember, probably, on LinkedIn. This was before I met any one of these guys, before talking to Bruno, before joining this community. And you were one of the most kind guys I reached out at the beginning of that year. So it's a pleasure to be in a talk with you months after our first connection. Maybe you remember now.
Yes,
So
because I was thinking about. I was wondering, where do I know Igor was a TDC? Where
no.
LinkedIn? Yes, yes.
Yeah, we didn't met on TDC yet. I wasn't able to join this year, but no, the next year probably I will be in one or two of them, for sure. So we will be able to meet each other all together, and it's also a pleasure to have all of your knowledge here and you as a person. You're a great guy, and
Thank
I'm
you
here
so.
more to contribute on questions and learning from what you have to
Oh,
share with us as well.
come on, guys! You are a reference for me, and I'm very honored to share this time with you and with this amazing audience. So I'm very honored and proud to be here. Thank you so much for the invitation. Thank you so much.
Thank you,
Thank
Isidro.
Yeah, thanks from our side. And yeah, so if you are watching us, please say hello in the chat and grab this opportunity. Professor Isidro, not just a great person, Java champion, but also he's great contributor for the community. I always see him sharing his knowledge, his experiences, and helping lots of people achieving their goals. So yeah, that's a great place to get in touch with such a great person. So yeah, I see Rico. He said here, pessoal gastando inglês. Yes, Rico.
We try. We try.
Yeah, here's the place where we only speak English.
Yes.
As we have spoken in one of the previous sessions, this is a prerequisite if you do want to go internationally. If you do
Yes.
want to go on your career internationally, this is a must. You do need to know technically everything we are going to see with Isidro, but English is like your main language if you're looking to work on anywhere in the world, even on remotely. So
Not only,
let's burn the English that gastar the English.
yeah, not only internationally, because even if you are Brazilian and if you want to know something from documentation, uh,
Yes.
usually the documentation in English is better.
If you
You,
need
yeah,
material up to date, any
yeah,
kind of information up to date, you will need it in English.
yeah. At least read. Yeah,
Yes.
And even
At
if you
least it's
are
in English. Let's imagine the worst scenario if it were in Chinese Mandarin.
Or
But
Russian.
yeah, I know.
Could be
Better
worse.
keep it in English for now.
Could be worse. Could be
Yeah,
Chinese. Could be Russian.
yeah.
Could be
It
Pakistanis.
way worse.
so yeah. Also, I see AGL say hello. He said hello here. Hello, AGL. Great to have you here with us. And yep, if you are, please share with us your questions. I will bring, since we have 1 hour of session here, and we already in the 11 minutes already, so I will give space for Isidro to bring the content and have enough time to bring all of his knowledge, because I believe that there's many things that he would like to share, right, Isidro?
Yes, but I'm going to use some a previous presentation that Gabriel and I told on presented on last TDC, but I think we can make a hands-on session
That's
because
amazing.
it's funnier to have practical examples using fundamentals applied on real problems.
Great. Yeah, our audience loves to have a hands-on presentation, so that would be great. Can
Oh,
I share your screen already?
okay, my screen is already. I think it's already shared.
So
Great, guys! Don't worry about the language. It's in Portuguese, but we are talking speaking English. But the main purpose of this session is to talk about the importance of studying. How can I say hard concept? I think hard concept could be a very interesting term to describe this kind of knowledge, because what's the main problem that we face today? Let's go there. We have lots of technologies, and the time to market, or our day by day issues, our day by day demands are usually urgent. And I think it's a problem to everyone, and a problem to most of who are watching us, is about can I how can I keep up myself up to date, and how can I study the- okay, hard skills, or hard concepts, and what to study, and why everything is important, why these concepts are so important, which kind of fundamentals can we make, how can we handle this kind of fundamentals, and what the companies can make it worth for us, how to make your roots stronger, and some kinds of examples. Okay, what we can do with this? For example, nowadays you have lots of frameworks, you have lots of tools, we have lots of infrastructure as a code, you have platform as a service, you have lots of tools to make your first simple applications. For example, if you are okay, I'm getting older, so my white hair can confess my age. And in the beginning, for example, in the beginning of Java, you know, you just have to make interfaces. You have the framework AWT or Swing. You have very limited resources. Nowadays, to make a hello world on a cloud native application, you have a backend service, a front end interface, you have to deploy your application on a container using a cloud infrastructure that you have to dominate, configure your private network, and set up your firewall and dominate and handle with Linux commands in order to put a simple hello world application starting. Just this. You can imagine, wow, it's a lot of things to make a simple application. And how can I don't get crazy with this amount of different tools and the amount of different technologies and what to use and when use and which kind of problem using this kind of technology this tool can solve my issue, solve my point, solve my problem. And lots of people that are talking to me, and the TDC was a very interesting example. I had the opportunity to talk with senior developers, and they asked me, and they were very worried about their careers and talking about, Isidro, I have lots of knowledge gaps on my formation. I'm a graduate on computer science, but lots of subjects, so lots of classes. I just went to go. I didn't learn anything on these classes, and now I miss this kind of knowledge. How can I fill this kind of gaps? So I'd like to talk about some kind of examples, because in lots of opportunities you don't you won't you won't have easy answers, because all of these problems are very difficult problems and are hard to answer questions. So how can we talk about in a very funny way in order to not be so massive? No. Okay, your customers, your companies, they don't have any kind of patience. They need solutions for yesterday. Okay, but this situation leads your career, leads most of our colleagues, our professionals, to stay only on the surface of the knowledge. You have no time, or you have no chance to study concepts a little bit deeper. So, what's the problem? If you stay only on the surface, you get your knowledge very limited to surface problems. And what we see now on our software industry, here in Brazil especially, we say companies are more severe on hiring new developers. The, for example, the onboarding process are much more severe. The selection of the hiring up of our developer is much more difficult to handle. The process is much more difficult. They are asking for data structure concepts, operating system concepts, software architecture concepts, distributed systems concept, and any other things, because companies are leading with much more complex problems, and they need more prepared professionals to deal, to handle, to solve these kind of problems. And how can we get developers with this kind of skills? Looking for developers who know fundamentals. Looking for developers, searching for developers who know hard concepts. Okay, What's the main problem? I like this kind of picture because usually we have lots of data. Okay, spread data along all of you study lots of things. You read lots of books. You watch lots of videos of technologies, but most of parts you can't transform this data into valuable information. Okay, if you can transform lots of things you consume into valuable information, it's a very, very, very good thing. But it's not enough because your information must be connected in order to you make like you build an internal toolbox on your brain. So if you can connect how those information can be linked to one another, it's very, very, very interesting to understand kinds of different tools that you have on your mental toolbox. You can even try to uh, identify problems and identify tools to solve those problems. And if you have a situation on you can make an insight, you can understand a problem and even identify a tool, but you can see this insight, and if you can connect all the path to solve this problem with the tools, with the uh, elements you have on your toolbox, you keep with you get wisdom. So what's the point? Currently we are more focused on this kind of on this window of this picture: information and knowledge. But we have to apply a lot of effort to shift this window, because this kind of situation leads you to solve difficult to solve very complex problems, because as more you know why you study some kind of subjects, for example, data structures or computer architecture or distributed systems or whatever, compilers, formal automata, formal languages, grammars, and so on, the most you study and the most you identify why and when you apply this kind of tools, more complex problem you are able to solve. That's the point. So why those foundations, those fundamentals are does matter? Okay, you need to solve very, very, very complex problems. Okay, let's try to do something. For sure you need logic. For sure you need programming logic, algorithms, okay, data structures, right, operating systems, as I said, Docker, for example, relational databases, and here I have a very specific point, and computer software architecture, okay. But relational databases are very, very, very important, because I guarantee you have already received on your network, your social network. For example, LinkedIn is I think is the most common example, when you received an infographic exploring or depicting different kind of join. inner join, left join, right join, outer join, cross join, and so on. Okay, full join and so on. And this is a classic example of inner join. Two sets with an intersection. Okay, if you study relational algebra, because relational algebra is one of the most math classes when you study databases on your university class, on your when you are at university. Okay, it was one of the most boring classes, relational algebra, but it is fundamental to understand that if you know a little bit of fundamental algebra, you will know that inner join is not intersection. Why? Why? Can you see an example? Okay, let's do an example. I created a database. Here I'm using MySQL. Okay, let's create a table called team. For example, we have a soccer championship. Okay, we have lots of teams that that matches other teams, right? So we have to make all the championship matches, all the championship games with one team goes against another team. Okay, for example, you have a home team and visitor team, right? Okay, let's try to do one thing. I'm going to create table TBL team, right? Soccer team, baseball team, basketball team, whatever. I have a ID, int, not null, primary key, right? And name, varchar 255, not null, right? That's my table definition, right? Right. Let's talk about NBA, right? I'm going to create all the matches of NBA, right? So NBA plays, right? Or NBA games, right? Which teams we have on NBA? Insert into TBL team, right? Values, right? One, Boston Celtics, right? And two, uh, New York Knicks, right? Right. So the other one, three, Los Angeles Lakers, and finally four. One suggestion: Boston Celtics, New York Knicks, Los Angeles Lakers, and I don't know. Los Angeles. I don't know. San Diego. I don't know. Let me ask one NBA team. NBA team. Let me see. NBA teams. Right. Indiana Pacers. Right. Indiana Pacers. Good. Okay. Inserted. If I make a select. Right. Select. Oops. ID name from TBL teams. Oops. Team. Not teams. Team. Right. Okay. All of my basketball teams are here. So I have to create all the matches involving all the teams of my NBA championship, right? Right. How can we do this? If I know a little bit of relational algebra, I know that the join operation can be a Cartesian product. What is a Cartesian product? a, a joining operation involving two relations, two tables on a relational database, it's about a relation let a Cartesian product that leads to a relation. For example, if I do this, select home name, visitor name from TBL team as home, join, only join or inner join, whatever. Okay, join or inner join are the same on MySQL. TBL team as visitor. What is the result of this kind of query? Let's see. Every team playing against other team. Indiana Pacers against Boston Celtics. Los Angeles Lakers as Boston Celtics. New York Knicks versus Boston Celtics, and Boston Celtics versus Boston Celtics. It's not a valid situation because these are home teams, these are visitor teams. Okay, first half of the championship. Second half, Boston Celtics versus New York Knicks, Boston Celtics, Los Angeles Lakers, Boston Celtics, Indiana Pacers, and so on. But we have coincidences here. New York Knicks versus New York Knicks, Los Angeles Lakers versus Los Angeles Lakers, Indiana Pacers versus Indiana Pacers. It is really an inner join operation. But what's the problem here? Just to make the things right. If I miss the term inner, it's okay, right? Right. Okay. What's the point here? Inner join is not intersection. Inner join is Cartesian product. What it means? I get all the elements of set A and combine with all elements with set B. For example, if I have four teams on my set home and I have four teams on my set visitor, I have 16 combinations, right? Right. But the main problem on inner join is to use the on clause, the on suffix, because home.id must be different than visitor.id. If we do this kind of, let me see, as home team, visitor team as visitor team, right? Right. From TBL team as home, inner join TBL team as visitor on. That's the key point. 99% of our situations using inner join must handle with equivalence of or equality. When we have given an element on a set, I must have the correspondent element on a set B, right? Right. But inner join is not limited to coincidences. Inner join could be and could be very, very, very oftenly applied with differences. Let's see. Oops, inner join. How can we do this? With this kind of simple query, we can have, for example, the complete list of matches involving all teams on my sets. Now we don't have Indiana Pacers versus Indiana Pacers. We don't have New York Knicks against versus New York Knicks. You don't have Boston Celtics versus Boston Celtics. You don't have Los Angeles Lakers versus Los Angeles Lakers. You know, if you know a little bit of relational algebra, you can know that this kind of representation is very, very, very limited. And this is surface knowledge. And what we proved here with code and our relational algebra could be a little bit deeper than the surface, right? Okay, let's keep going. Inner join is a relation, so it's a operation involved related to relations that creates another relation uh, according to your restriction. Right, right. Another example that you can have can be over informed, misinformed about another hype on social networks about big O notations, algorithm analysis. You have a lot of experts on social networks that tells you you have to study big O notation. You have to study big O notation. All right, very very interesting. But what does big O notations mean on real world? What this mean? For example, if you have to search an element on a list, a simple list, an array list in Java, what it means compare it to a search of an element on a hash map. What is the difference? What is the difference using a non-indexed structure and an indexed structure? List don't have indexation. Array hash map do have indexation. How can we do practically in practical terms to understand what does big O notation mean? Can we do some kind of code? Okay, let me share my Eclipse. Right. Create a Java project. Let's do something about Java. Don't don't want modeling info.java, and let's talk about list benchmark. Okay, list search benchmark. Search benchmark. Benchmark. Right, right. Okay. So, oops. I have a I have a small problem here because I didn't link to. Let me do okay unbounded. Let me try to okay edit right workspace default right. Yeah, just a default. Perfect. Let's do. I think just one class is enough. Okay. No. Product one. A class product. Right. Okay. And let me try to. Right. I think it's better to understand. Private integer ID. Private string name. Private double price. Right. What's the main problem? I want to create a constructor and getters and setters, right? Okay, perfect. What will I do here? I'm going to create a main class, and this class will be my benchmark. Main class, right? And this will have main method. Okay. And step one, let's create a list using list, right? Right. Using list. Step one, create a very, very, very huge list. So, Okay, let's int size like 1000. It's not a very, very, very huge list, but I'm going to increase this. 10,000. Okay, 10,000. Okay, so I'm going to declare a list of products, list, new array list, product, right? Okay, and I'm going to fill this list. Okay, for I plus plus, list add new product, I product I and I multiplied by 10. Okay, created a list, right? Right. What we were do? Long start and right and start. I'm going to measure time. Okay, current time millis, right? And system current time millis, right? And search took and slash start. Okay, milliseconds, right? I'm going to do this several times, okay? Several times. And int count, starting at 0, count 1000 searches, 1000 repetitions, right? Okay, iterations. Okay, I'm going to count your right. So, step 2, let's search the last element on list. Why? Because I'm talking about the worst case. The worst case search on a list is to find the last element or not found, because you have to search you have to traverse all, check all the elements of your list and conclude that this element is not found. Okay, so I'm trying to uh, 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 lead to the worst case. I'm going to search the last element of my list because I have to start on the first element and go through every element until reach my last element on the list. Okay, okay. What do we have to do? For int position, starting in 0, position less than size, position plus plus. Right. If list dot get position get id equals, let me put one element, integer id to search equals size dot one, size less one, right? Right. ID to search, break. Okay, that's the point. So we are going to take how long does it to measure how long does it takes to search one element among 1000 element 1000 times. Okay, okay. Let's make a little small benchmark. Let me put a notepad to make my notes. Okay, list size and time. Okay, list size 1000 elements, 123 milliseconds. Okay, okay. If we increase, 10,000, sorry, 10,000. If we increase to 100,000, how long does it take? Let's see. Oh, whoa, 2.4 seconds. Okay, so 69. Okay, 69 microseconds, milliseconds, sorry. And if you have 1 million elements here, how long does it take? Okay, 1 million. Let's put another case. Okay, it will take, I guess, about 20 or 30 seconds. Okay. Okay, what is the main message of this kind of test? As my list increases in size, the time to search increases also, right? It's not, let's see, 16, almost 17 seconds, okay? Almost 17 seconds, right? So 16, 949, 929, 929 milliseconds. Okay, so if we change our data structure, a hash map size, what is the time? Okay, let's try. So I'm going to comment this kind of, let's try here. Okay, let's start with 10,000, right? Okay, so I'm going to comment this. Okay, okay. So I'm going to just make this, oops, copy. Okay, and this I'm going to reuse. Oops, let's reuse this and this one. Let's see here, this one. Okay, okay. So again, step one, fill the hash map. Okay, hash map of product and integer and product map. New hash map integer and product. Right? Right. Okay, perfect. So let's fill this map. Map of for int I starting 0 I less than size I plus plus map dot put I and new product I product plus I multiply by 10. Right. Okay. Okay. I fill the map. Right? Okay. What's the point? Let's search. How many times we're going to search? Okay, 1,000 times. Again, okay, I'm going to search 1,000 times, but the search now is different because I don't have to go element by element on my hash map. It's an indexed structure, right? Index structure, because I just have to if map dot get id to search different of null break, right? That's the point. I don't have to do this. Okay, so do nothing. Okay, do nothing. Just this. Okay, what's the point? It's a different data structure. Yes, because it has another asymptotic complexity. That's the point. So if we have a 10,000 element size, how long does it take to search elements on a hash map? Wow, let's do it again. 1 milliseconds. Okay, okay, that's our reference time. Okay, for 10,000 elements, 1 millisecond. Okay, and about 100,000 elements. Let's do it again. Okay, 100,000. Whoa, let's do it again. come on. 1 millisecond. Okay, 1 millisecond. Okay, 1 milliseconds, right? And what about 1 million elements using hash map? 1 million. Okay, let's do it again. Oh my god. Oh my god. What does this mean? What is when someone says about the asymptotic complexity of an algorithm is on big O notation, linear, as your set, your list, your elements, your set of elements increase, your time, your execution time also increase. Okay? Linearly, maybe, because you have other things here. But if you have a complexity, or asymptotic complexity of an algorithm, and in this big O notation, it's constant. For example, hash map, you see that the size of your set does not matter because non-indexed structured, you have constant time. Even though your structure have 10,000 elements, 100,000 elements, or 1 million elements. Can you understand that? This is big O on real cases. This is how can you measure time on your big O applications, right? But big O application also have its limitations. Why? Why? Let's see. Look at this. Big O notation is not the main point to declare that your algorithm is correct or not. Let's do one example. One simple example. Another benchmark. Okay, this is the search benchmark. Okay, okay. Let's create another benchmark. Oops. New. Oh, sorry. New Java project. New Java. Oops. New Java project. Okay. The folder. Matrix benchmark. Benchmark, right? Okay. What is the matrix benchmark mean here? Let's try to fill a matrix. Okay. So main class, right? Main method. Okay. So double matrix. Let's do int size. I think 5,000 elements is okay, right? Okay. New double size and size, right? Right. Let's see if it runs, does not do any exception. Okay, perfect, perfect. Let's fill line by line. Okay, okay. So for I starting 0, line, 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 less than size, line plus plus, right? Int line, right? Okay. For int column, row column, row and row. Okay, and column starting in 0, column less than size, column plus plus. Matrix in our row and column, receive 1. That's it. So let's measure how long does it take. Long ini start and start system current time millis, right? Right here, and system current time millis. Okay, so let's print this out. Matrix filled in, and let's start milliseconds. Okay, so 54 milliseconds. Okay, let's try a greater number, 10,000. Let's see, let's try. Okay, look, 10,000 by 10,000 matrix filled row by row in 273 milliseconds. Okay, okay. If I just change the way I fill in the first example, row by row. In the second example, column by column. Look at the difference. Look at the difference. Why? A theoretical developer can look this code and say, okay, filling a matrix, it's a square complexity. Okay? Yes. Size elevated to square. Size elevated on 2. Okay? Okay. N, square n. Okay. But the same theoretical concept leads to different practical results. Why? I didn't change almost anything. I didn't change the structure of our instruction. I just changed the way I fill the matrix. Right? Right. What's the problem here? The problem is not your application. This kind of result is not due to your application. It's not due to the complexity of the algorithm. It's due to computer architecture. Why? Why? Let's try to do one thing. I'll try to draw something. How can I draw this? I know, Xcode draw. Xcode draw can be a very interesting tool. Let me see. Okay, let's try to. Okay, let me put here. Okay, uh, I think I could make. I don't know. Oh, okay, light mode. Right, much better. Okay, we know we don't have matrix representation on our memory. It's just a vector. It's just an array. Okay, so let's consider that we have a matrix of 3 by 3, 3 lines and 3 columns, right? That's our matrix. Okay, but we know physically on our memory that we have what? This kind of array. Okay, it's a contiguous array on our memory. This is a matrix. Okay, matrix abstraction and array physical representation. Okay, okay. What's the point? If I have to fill the matrix row by row, I have my processor here. Okay, processor. Let's let's see this processor. And processor can handle main memory. Okay, but first we have another thing here. It's called cache. Oops. So if you know a little bit of computer architecture, you know that before your processor access the main memory, the RAM memory, it accesses the cache. If your data is not present on cache, you have a page miss, and you have to invoke to your operating system what? A change of pages. When you go to access your data and you feel, I'm going to do this kind of, just to separate our rows, right? Just for notation. Row number one, row number two, row number three. Okay, just to know. Okay, row one, row one, row two, row three, right? Physically on memory. Okay, row two and row three. Perfect. Okay, when you access your memory, there's a property on your operating system that it's kind of property of referential localization, something like that. What does it mean? You don't bring one single variable or one single data to cache. You bring a whole frame, memory frame to your cache. Let's suppose our memory frame have the same size of just one row, right? Just this is just for a test. So if I need to go to bring to access the first line, the first element of the first row, first column of my matrix, my operating system brings the whole line, the whole row to cache. And it's easier to our processor to handle these three data here. If I need to access the second row, there's a page miss. I can bring back the data, overwrite the data on memory, and bring another page. Okay, oops, sorry. Okay, let's bring another page. I can fill the three elements, access only cache. Okay, let's access the third row. Okay, page miss, bring it back, and finally bring the third row, right? How many memory access did we have in this case? Three memory access, right? Right. Okay, I'm going to fill in this way, column by column. Okay, first element of the first column, I bring the whole row. Okay, just the first element. Oh, I have to access the second one. Bring back and take the second row. Okay. Okay. Fill the first element of the second row, right? The first column of the second row. Have to fill the third element. Bring. Oh, good. I have to fill this second column of the first row. Bring back. Oops, sorry. Bring back and take the first row again. First row again. Okay, fill the second element. Right. Now, second row, second column of the second row. Bring back again the second row right here. And so on. And for the second column of the third row. Okay. And finally, the same process for the third column. How many memory access? How many memory page miss events did I had in this model? 9 instead of 3 of the first approach. You know that theoretically, this code filling a matrix row by row or column by column theoretically have the same asymptotic complexity. But when you go to real case, when you go to code, when you understand that it's a part of the problem that you have to understand algorithm, memory organization, operating system, and computer architecture, you will realize that the theoretical complexity is just one point on your application performance. These three kinds of elements can be very, very, very interesting that you have to know what your problem is very, very, very complex. It was a simulation of our problems here, but all of those subjects leads to one thing. Everything on your formation is connected. Software development is not about only programming language, databases, or web development, or front end, or only back end. Most of times, or in lots of situations, you have to know about computer architecture, algebra, language, automata, graph theory, data structures, software engineer, uh, distributed systems, operating systems, computer networks, and so on. Everything on a computer science course is connected to improve your skills to make better software and to understand why your software could be with a very bad performance or why does your software crashes, right? So try to exercise your fundamentals, try to read the classic books, try to read Tannenbaum, try to read Corman, try to read uh, Stallings on computer architecture and any others. That's the main point. Questions, guys? That's, I think I'm done with my content. I hope you enjoyed, people.
Was really amazing. I was I was surprised. I never did your example of the filling the array, the matrix in different forms. So yeah, it was really interesting to see connecting all the things. Right? It is the theoretical with the hardware, the computer architecture. So that's great way to actually see it working and how it affects. We see that the time it changes a lot
Yes.
by that changes, right? Yeah, really good. I am if you are watching us and have any questions, you can place here. Uh, but I want to ask Isidro. I
Yes.
know that you also have courses or content that can help anyone to get further with those fundamentals. I think people would like to know how can we actually go after those content and go further, go deeper into these concepts? Do you have any suggestion regards to that?
Uh, I always suggest to my students to go a little bit, uh, try to read the classic book. I have some classic books that I keep beside me. Let me just explain. For example, it's a very interesting book. Oh, let's see if I can. Oh my God.
Yeah,
Okay, the camera
you
is
have to
back.
put close to your to your head, to your
Data
face. Yeah.
structures using C language.
Let me just put you bigger here.
Oh, thank you so much. Data structures using C. Why C language? To understand pointers. Pointers are very difficult to understand. We are Java developers. Java is easy to to study pointers, but because you don't have the complex syntax of C language. Another one, memory management, data structures, algorithm complexity. It's a very, very practical book. I like this book a lot. So, another one, this one, Fundamentals of Database Systems. It's a book. This version, it's let me see, 1994, the last century. It's a book from last century. It have 30 years old. What is the point? It's very, 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 very current. It's all the fundamentals of relational algebra are here. Oh, okay, are here. I extracted all. Oh, I have only the mark of the page here. Page number 153, relational algebra. So these kind of books are very important for our information. Operating systems, Tannenbaum, operating systems, Tannenbaum computer architecture or William Stellings, Tannenbaum distributed systems, Corman algorithms. It's a very, very hard book to understand. Another one, uh, uh, the Dragon Book, Aho and Ullman, compilers, principle and tools. Compilers is a to create a compiler. It's your greatest exercise as a developer because it's hard. It's very, very, very hard. I think I have a
Hey, Professor, I have a question for you.
please, Igor.
Yeah, since you just showed us a lot of books about a lot of fundamentals, and
Yes.
this was awesome to understand. And how can we put this for someone that is a junior and that is starting his career to not be scared on seeing off these huge books and just trying to look on something else? Because from what I understand is you build this knowledge through the years
Yes,
for a whole career.
because I always say career is like a role playing game. It has no end. Your career has no end. And if you know that you have to study for your whole life, it's okay because you don't have, for example, I will not be an expert on operating systems reading a book for the first time. For example, I started coding when I was 11 years old. I'm currently I'm in 45, 40, 46, 46 years old, 35 years old, coding almost every day. Okay? So I still open the same book that I opened 30, 25 years old when I was on graduation to read it again, to understand concepts that I missed before, to try to understand new things. So a junior, usually a junior is still a student, usually, commonly. And what do I suggest? Try to make the best graduation course as you can. I'm not talking about an institution. I'm talking about your attitude during your graduation because you have to enjoy your journey. There are no useless technical classes. There are no useless technical disciplines. For example, most of my students hate data structures. Why? Because it's difficult, right? It's difficult to to make, for example, an algorithm to traverse a tree is not easy. You have to know recursion. You have to know to have an abstraction on your mind. So try to understand and to study this, because your capacity to solve complex problems when you are still studying, when you are still on your formation, is very, very, very uh, power potentialized. So try to make the best course you can do on your attitude to understand and to uh, apply the concepts you are studying during your graduation. I think it's a common advice that I do to that I give to my students.
That's great. That's a good one. And the more you practice, the more you will get familiarized with that. It will
Yeah.
be tough at the beginning, but eventually things start to feel easier, and then you understand it better, then you get deeper on that subject and you apply it in your daily, and this is how you evolve
Yes.
everything.
And try to not try to know that your knowledge takes time. Knowledge takes time. You have to respect this for your mental health. You have to respect time.
That's an important point that you mentioned, because I've seen people that have worked with me when were back when I worked in the Brazilian market. They were kind of juniors. They wanted to go so quickly, and that they were working from the morning until night, and they got mad. No, that's not how you do. You do need to have time to live.
Yes.
You can forget about being the geek in the cave that doesn't see the sunlight.
No.
You will get sick. You
Yes.
will get sick. You want to learn step by step every day. The secret is consistency, and not getting it all at the same time, because you will burn out.
Consistency is more important than intensity.
Yeah.
A little bit. I have an example. You have to eat 30 breads on a month. If you eat one bread a day, you can eat 30 breads along through a month. So if you pass 29 days not eating any bread, you won't be able to eat the other 30 breads in just one day. It's a very, very simplistic association, but it's related to consistency is more important than intensity.
Yeah, on everything. Yeah, it makes total sense.
Yeah, I have a question too.
Yes, please.
So, some courses in Brazil, especially in Brazil, have a more practical approach, where
Yes.
students learn through projects like our undergraduate technological courses, right?
Yeah.
Um, I think is more common in Brazil. What do you recommend for these students in particular? Because although they may have chosen this kind of course exactly because it doesn't have so much theory, they should try to learn the basics with extra courses. And of course, this theory combined with practice,
I think
because your life code was very nice.
because I think you have to expose yourself to complex problems. Expose yourself will lead you to study uh, on demand. Of course, if you are a technical, if you made a technical course, you are trying to go to the market earlier. That's one point. And probably you will have no time available as you had before. So you try to you go to your job, and your life will be more and more and even complex, and even more and busier and busier. So what do I try to recommend? There is a lot of free material on the internet. It's very interesting. Data structures, graph theory, algorithms. But if you try to understand and practice algorithms, database, for example, HackerRank, LeetCode, bCrowd are very fantastic tools to practice the basis of logic, algorithms, and databases. That's one point. The second point, try to make a little bit more complex project. For example, a parser or a regular expression builder. It's very complex, and it's very difficult, and you will face different uh, subjects that will stuck your project. So you have to stop and study, and to be able to keep going. Of course, if you are on a university course, you'll be obligated to study this kind of boring classes. But if you do this for your own will, it will be much more difficult. Much more difficult. But it's possible. But it's very difficult. Because it's not fun. It's not fun, but it's necessary. It's like the food you don't like. I don't want salad, but you have to eat salad. So just eat. It's very as long as the time goes by, it gets more and more difficult to change your mindset you know
So on your own, maybe you're more motivated because it's something you want to learn, but it's
Yeah.
more difficult because you have to do this by yourself.
For example, could can be a very interesting point of motivation. This it
Cool. And
There's also another approach that you can use to get it more in depth on that. I've used that in the past. I needed to go deeper. Let's put an example on some of the engineering behind this offspring. So I started with the surface,
yes,
as you've
use
mentioned. That's the basics. So I don't know how that works. I don't know how that implements, but what I needed to change how the default engine from Spring works. So I do need to understand how that works behind the wheels. So you start getting deeper on that. You start to override classes from Spring, you start to change its behaviors. So you are learning how that works behind the wheel. That's also a way of learning these as well. If you do have the fundamentals, if you don't have any fundamentals at all, you will get very lost. You need to learn a lot more to understand how that works.
we make an exercise. I made this kind of exercise with my students. We created I call it nano spring framework to be a concurrent of spring. Obviously not, to learn, because when you use the spring framework, you have a servlet behind. What is a servlet? What is the embed tomcat? How can you find classes to inject on your service, for example? So that's the main reason. Try to reproduce a technology you use. Don't be only user, technology user. Try to reproduce, try to make a subset of your the technology you use on your day by day tasks. It's an amazing thing, and you can open your mind to suggest solutions that you could never imagine on your company.
Cool, really cool. So I think we already passed our time, but
Oh,
I think it's for a good reason. We are here with a celebrity developer. So, but
come on.
it was really great to have all these tips and the demo code to show how everything works and connects with this knowledge. So once again, thanks a lot, Isidro.
Thank you
I
so
see
much,
here on the
guys.
chat some people say hello or make a hand purple blue piece. Ajisha, Johnny, and also Guto Silva wrote here. Great advice, Isidro. So,
Guto is
yep,
a very, very good friend. Thank you so much, Guto.
amazing. So yeah, that's it. If you do you have any last word that you would like to share with the audience, Isidro?
I just want to say thank you to you guys. I'm very honored to be here with you to talk your with your audience. For me, if you want to meet me on social networks, just look for Professor Isidro, and I'm here to help. I think that the best part is try to help the community.
Great, great. Thanks a lot, Zen, and hope to see you on future sessions, Isidro. You're always welcome here.
Just call me. I'm here to help.
Great. So
Thanks a lot for
thanks everyone.
joining,
Oh,
Professor. Thanks a lot for
That's my
joining us, Professor Isidro. It was a pleasure to have you here. Pleasure to talk to you here, not in person yet, but on the live. And thanks a lot for bringing all of this knowledge. The way you explain is exactly like a teacher would be, and this importance of fundamentals on your career on the technical side. That's key. It's very funny because I were looking today earlier on my pictures on Google Photos, some old photos from 2016, and I found an image of a picture that I took back then, and I were practicing some Java structures on the balcony of my mom's home when I lived back then with her. So
amazing.
fundamentals is something you have to keep being practicing. It's like going to the gym. If you don't exercise it, you lose it. And that's the same with communication. That's why we are practicing English here as well, showing this content to the whole world, since more people from outside of Brazil and all other non-Portuguese speaking countries can get access to this too. Thanks a lot, Isidro. Thank you, Hugo and Luis. Great content, and it's a pleasure to have you here today, Isidro.
Thank you so much, guys.
Yeah, Isidro, thanks again for being here with us. And I just want to say one thing: live code isn't for everyone. It was amazing. Thank you for this experience.
live code with SQL queries. I think it's
It-
another level as well.
it's hard, right?
I had a
Yeah,
lot of fun.
Yes.
another level.
It's like the live television. It's not for anyone.
Yes. Thank you so much, guys. I had a lot of fun here.
Great,
Awesome.
Isidro. Thanks a lot. So,
See you
for you
guys.
that was watching us, see you on the next session. Bye bye.
Bye bye.
Bye bye. Take care.